for example 7, I'm going to show it to you twice. Not necessarily because, you got to do a problem twice to make sure you get it right, just because on the second time I'm going to show you a simpler way to have accomplished that, one that maybe is not quite so obvious. Okay, so let's take the derivative of f of x is equal to the natural log of the square root of x plus 1. But before I do that, I'm going to rewrite this as the natural log of x plus 1 to the 1/2 power. All right, so f prime of x is equal to, it is natural log, so I get to just do a u prime over u. I'm going to start this with 1 over x plus 1 to the 1/2 power, and then multiply it times the derivative with respect to x of x plus 1 to the 1/2 power. Okay, so on this part, of course, I'm going to leapfrog this guy down and use the power rule on it. Let's bring the other stuff down, though. All right, and then I'm going to leapfrog this power down, 1/2 times x plus 1 to the negative 1/2 power after I subtract 1. Now multiply it times the derivative of the interior function, which is 1. Don't forget, let's multiply it by 1. Oh, and so it's not confusing, I'm going to put it in parentheses. All right, let's maybe clean this up just a little bit. 1 over, I have this as the square root of x plus 1 times, let's see, 1 over 2 times the square root of x plus 1 since it's a negative exponent, and then let's bring down our times 1. All right, and then maybe multiply these things together, this square root times this square root. Those square roots are going to cancel, and then my final answer here, f prime of x is equal to 1 over 2 times x plus 1, and then I just multiplied this 1 up top here, so that 1 times this 1 times that 1 is just this 1. All right, there you go. Lovely. All right, I think that there's actually an easier, faster way to have done that, which I'm about to show you right now. So remember that our function was this. It was the natural log of the square root of x plus 1, but we rewrote it as natural log of x plus 1 to the 1/2 power. And now I'm going to just use a property of exponents, which allows me to take this 1/2 and bring it out on the outside. The product property, 1/2 times the natural log of x plus 1. All right, and now let's take its derivative. F prime of x is equal to, so 1/2 is just going to come along for the ride, and then we're going to do a u prime over u. The derivative of that's just 1 over x plus 1. Ta-da! So all of that to say that when you have some sort of logarithm that you are taking the derivative of, check to see if you can maybe expand that thing out using some properties of logarithms, because it often will make your job a lot easier. You know what? We could have done that back up here on number 2. So on number 2, we had f of x is equal to log base 2. Remember, it doesn't matter if it's natural log or whatever log. The log properties still hold. X times the sine of x. Okay? So this is the log base 2 of x plus, since it is a product, it turns into a sum of 2 logs. The log, man, I just want to write natural log so bad. Log base 2 of sine of x. And now just do your u prime over u, 1 over x on this one, and then we have to also make sure that we multiply this by the natural log of 2 on the bottom, plus, let's see, the derivative of sine is cosine x over natural log of 2, just like we had before, sine x. All right, and yeah, that doesn't look exactly like that, but it can be if you get a common denominator. Common denominator, you multiply these two things together, except for they both already have a common factor of natural log, so you wouldn't multiply that part. So the common denominator would be the natural log of 2 times x times the sine of x, right? And the first one is missing its factor of sine x, so it gets multiplied by sine x. And the second one is missing its factor of x, so plus x cosine x. Well, on that one, I'm not entirely convinced that that method was necessarily shorter, but on this one, it certainly was. So back over here on the slideshow, a little summary of this. Here's that first method. Here's that second method. Definitely a lot more elegant. And then here it is, just kind of summarized. Sometimes it's convenient to use some properties of exponents to simplify a problem before you differentiate.